Hello sir, I'm Nihitani from ECE department section B. My topic is representation of alternating quantities. First of all, we'll see about analysis of AC circuits. Alternating functions or AC waveform, on other hand, is defined as one that varies in both magnitude and direction in more or less an even manner with respect to time, making it a bidirectional waveform. An AC function can represent either a power source or a signal source with the shape of an AC waveform, generally following that of a mathematical sinusoid, being defined as a of t is equals to a max into sine 2 pi ft. The term AC, or to give its full description of alternating current, generally refers to a time varying waveform, with the most common of all being called a sinusoid, better known as a sinusoidal waveform. Sinusoidal waveforms are more generally called by their short description as sine waves. Sine waves are by far one of the most important types of AC waveform used in electrical engineering. The shape obtained by plotting instantaneous ordinate values of either voltage or current against time is called an AC waveform. An AC waveform is constantly changing its polarity every half cycle, alternating between a positive maximum value and a negative maximum value, respectively, with regards to time, with a common example of this being the domestic mains voltage supply we use in our homes. This means then that the AC waveform is a time-dependent signal, with the most common type of time-dependent signal being that of a periodic waveform. The periodic or AC waveform is the resulting product of a rotating electrical generator. Generally, the shape of a periodic waveform can be generated using a fundamental frequency and superimposing it with the harmonic signals of varying frequencies and amplitudes, but that's for another tutorial. AC waveform characteristics. The period t is the length of time in seconds that the waveform takes to repeat itself from start to finish. This can also be called the periodic time of the waveform for sine waves, or the pulse width for the square waves. So this will be called the periodic time for the sine wave and pulse width for the square waves. The frequency f is the number of times the waveform repeats itself within 1 second time period. That is, it should repeat the same diagram, or it should repeat the same loop again and again. That is called frequency per second. Frequency is the reciprocal of the time period. F is equals to 1 by t, with the unit of frequency being the hertz. The unit of frequency is hertz, we all know it. The amplitude A is the magnitude or intensity of the signal waveform measured in volts or amps. The amplitude is measured in volts or amperes. So the amplitude is the magnitude or intensity of the signal waveform. The most common periodic signal waveforms that are used in electrical and electronical engineering are the sinusoid waveforms. However, an alternating AC waveform may not always take the shape of smooth shape based around the trigonometric sine or cosine function. AC waveforms can also take the shape of either complex waves, square waves, or triangular waves, and these are shown below. So the first one is sine wave. Sine wave is a bit of curve, and it is repeating. The period of this sine wave is pi. So this is plotted between amplitude and time. The second one is complex wave. Second one is complex wave. This is a complex wave because it doesn't have any shape. We can say sine wave is a kind of curve, and this is a bit of different, so it is a complex wave. The third one is triangular wave. Triangular wave is upper half is also a triangle and lower half is also a triangle. Here also this time period is 2 pi. The next comes the square wave. This is a waveform. Upper and lower halves will be squares. Okay, so the time taken for an AC waveform to complete one full pattern from its positive half to its negative half and back to its zero baseline again is called a cycle. So the time taken for an AC waveform to complete one full pattern from its positive half to negative half and back to its zero baseline again is called a cycle, and one complete cycle contains both positive half of a cycle and a negative half of a cycle. So whenever we say it is a cycle, it should contain both a positive side and also as well as negative side also. The time taken by the waveform to complete one full cycle is called the periodic time of the waveform. So periodic time of waveform is one complete cycle and is given the symbol T. The time period is denoted with a symbol T. The number of complete cycles that are produced within 1 second is called the frequency. As we discussed before, the number of cycles completed per second. What is a cycle? A cycle is it contains a pattern. It contains positive half and negative half. So that cycle produced per 1 second is called as frequency. The symbol of frequency is F. The alternative F of the alternating waveform. Frequency is measured in hertz. As we discussed earlier, frequency is measured in hertz. It is named after the German physicist Heinrich Hertz. It is denoted by H and Z, a capital H and a small z. Then we can see the relationship that exists between the cycles, that is oscillations, periodic time and frequency. Frequency is cycles per second. Periodic time is the complete cycle. The time taken to complete one full cycle is called as a periodic time. Number of cycles per second are called the frequency. What is a cycle? It is an oscillation. It contains a positive half and a negative half as well. So if there are f number of cycles in 1 second, that is f is a frequency. If the frequency is f and each individual cycle must take 1 by f seconds to complete. 1 by f is again t, that is time period, right? It takes t seconds to complete. So the relationship between frequency and time period will be 1 by periodic time is equals to 1 by t hertz. Frequency is equals to 1 by time period. So periodic time, again reverse. Periodic time period is equals to 1 by frequency, seconds. The time, it's a time, so which will denote it as seconds. The average value of AC waveform. The average or mean value of a continuous DC voltage will always be equal to its maximum peak value as the DC voltage is constant. The average mean value of a continuous DC voltage will always be equal to its maximum peak value as the DC voltage is constant. This average value will only change if the duty cycle of the DC voltage changes. So the original cycle of DC voltage, if it is changed, then only the peak value will be changed, otherwise it will be same. In the pure sine wave, if the average value is calculated over the full cycle, the average value would be equal to 0 as the positive and negative halves will be cancelled out and will get 0. It is in the case of pure sine wave, if the average value is calculated for the pure sine wave for the full cycle, over the full cycle, then the average value would be equal to 0. Why? Because positive and negative halves will be cancelled out. So the average or mean value of an AC waveform is calculated or measured over a half cycle only, and this is shown below. We can see the graph here. The positive peak is plus Vmax and the negative peak is minus Vmax. We can see the length there, that is a positive half cycle. this is a positive half cycle. This is a positive half cycle, and this half will be the negative half cycle. This is a graph showing average value of a non-sinusoidal wave, that is a complex wave type. The average value will be the addition of all the instantaneous values added together and then divided by total number. This is given as average value of an AC form is given as V average is equals to V1 plus V2 plus V3 plus V4 and so on up to Vn by n, where n is the number of quantities, number of instantaneous values we get. The average value will be the addition of all the instantaneous values added together and then divided by the total number. Thank you.